Okay, this is section 7.3, exercise 16. And in this, I have this region that they're talking about. So this comes from y equal 1 minus x, and we are going from x equals 1 to x equals 3, I guess, and 1 minus 3 is negative 2. Okay, so we have that region, and they're saying we want to revolve this region around the x-axis, and we want to use a shell method. So our shell is parallel to the x-axis, and it will go around this way. And so as we look at that, we see that our radius is equal to the y value, actually the absolute value of the y value. So we'll have to be careful of that. That's our radius, and the height is going to be 3 minus our x value. Okay, so we have to think about that, 3 minus our x value. Now, the thing is, remember, we're taking shells that are parallel to the x-axis, so we're actually marching along here, and but we'll be going from -2 to 0. So at this point, I know I want to go from -2 to 0, and I know I want to do this with dy, and I know I need 2 pi. Then I need r, which is the absolute value of, let's see, of y here. Okay, so it's actually the absolute value of y. So how do I do that? Well, actually, I just make it negative y. So there's the absolute value of y, because y is always negative. Okay, so I'll use a negative y. And we'll know we messed up if we get a negative answer. That's for sure. And again, I could do this much like I did the number 2. I can determine the answer without all this integration stuff. And so maybe we should do that before we actually integrate, or maybe we'll just do it after we integrate to check it. So I have my minus y as my r, and then the height here, it goes from 3 to whatever x is. Oh, okay, so I need to get my x in terms of y, so that's x equals 1 minus y. And so if I take 3 minus 1 minus y, I have my h. So see, this is my h for that soup can. And so we have 3, well, that's not h. 3 minus 1 minus y is h. So 3 minus 1 minus y. And there I have that. So I'm going to put that back down here. So 2 pi from -2 to 0 minus y times 3 minus 1 minus y dy. And that is equal to 2 pi integral from -2 to 0. I'm going to leave the minus y there for a minute, the minus on the y for a minute. Wait until I see what I get here. I get 3 minus 1, so that's 2, and then a minus y, so that's plus y. So at this point, yeah, I want to move that negative out, dy. And and again, we'll see. I'm pretty sure I did that right. Minus 2, 0. Multiply through by the y, I get 2y plus y squared dy. And so this is minus 2 pi. And integrate this, so I get y squared plus y cubed over 3 from minus 2 to 0. Now, 0 makes 0, and so I get minus 2 pi times a negative 1 times. Now, I have the negative part because I have to subtract this stuff off. Times, and then I'll put the negative 2 in. So I get negative 2 squared plus a negative 2 cubed over 3. And notice here I've got the negative and the negative. That's going to make a positive. I hope that's a good thing. So that's 2 pi times 4, and then minus 8 over 3. Yes, that is a good thing. So 4 minus 8 over 3, that's 12 over 3 minus 8 over 3. So that's 4 over 3. So we get 8 pi over 3. So that looks good. I mean, it's a positive number and all that. So hopefully that's correct. Now, again, we can check this because this, once again, is just a cone. The radius here is 2 because I go from here to there. And the height is also 2 because I go from, the 1 to the 3. And so, once again, I can take my pi r squared h for my cylinder, and that's pi times 2 squared times 2, which is 8 pi. And then divide by 3. And I get 8 pi over 3, which is what I had there. I think we did something right. So again, the shells, we make the shells parallel to how we rotate, the axis we rotate around. Okay, so there is number 16.